What are we learning today?
All right, here's something everyone can do at home. And if you have a younger sibling, you can make them think that you're doing a magic trick. You probably did this if you played in the bath as a little kid. I used to do this as a little kid, and I would stuff toilet paper in there, but right now we don't want to be wasting toilet paper. I really don't want to even be wasting paper towels, but anyway, for the sake of science, we'll waste a couple paper towels. Okay, so this is so simple. You can do this at home.
What is this called?
A beaker.
Okay.
Big
You know,
beaker.
there was a Muppet character called Beaker.
No, I didn't grow up with the Muppets. Okay.
He was a scientist.
Oh, was he?
Yeah.
Okay, cool. Thank you for that information. I feel much better now. Okay, here's a big beaker and here's a little beaker. This beaker has water in it. I'm going to put my paper towel down on the bottom, and then I just want it to stay in there. And then I'm going to push it down below the water, and I'm going to hold it, and then I'm going to pull it out, and I'm going to take my paper towel out, and my paper towel is still dry. And it's shocking to me how few students know this. So if you do already, don't be offended. Show it to your younger brother or sister or cousin, and they'll think you're doing a magic trick. Now, why does that work? That works because when I turn this beaker over in the water, it's full of air, and air exerts pressure in all directions. So when I lower this in there, the air is holding that space, and the water can't rush into it, unless, of course, I tilt the beaker.
So we're at atmosphere, and I've got this beaker, and it's holding the air.
Yep.
But we're only exerting a finite amount of pressure on this.
Yep.
What if we had a super deep swimming pool and I could swim this beaker carefully down? What would happen as I descended deeper into the depths?
Well, as you descend deeper into the depths, and you know this better than me because I can dive like 3 feet and you can dive like 70 feet. But what you know is as you go down, the pressure increases.
Right.
So what would you expect the volume of air in there to do as the deeper you went down?
The deeper you went down, so I think around 30 feet is an additional atmosphere.
Yep, 10 meters. Every
Right.
10 meters, about 30 feet.
And so at 0 feet, which is 0 feet, we're at 1 atmosphere.
Mm-hmm.
So if we went down 30 feet, we would be at 2 atmospheres. And I think 60 feet, 3 atmospheres, 90 feet, 90 feet, 4 atmospheres, I believe.
And now, because of P1V1, that means it's an inverse. As pressure goes up, volume would go down.
Exactly.
And so maybe next time you go scuba diving, you can take a beaker down with you.
I might. So for all you people who don't care about chemistry but like fishing, so that's called, this principle generates barotrauma in fish. When you're out fishing, you're deep dropping, catching queen snapper, silk snapper, or some kind of crazy,
Amberjack.
You could catch amberjack, or misty grouper or something. When you reel them up from the depth, maybe you caught a big red snapper out in the Gulf of Mexico out deep, you reel them up from deep, their swim bladders blow up. They had a small amount of air in their swim bladder down on the bottom, which was keeping them buoyancy compensated, so they were neutrally buoyant. That small amount of air in their swim bladder, when you bring them up, the pressure drops dramatically from, let's say, 200 to 300 feet up to 0. The pressure drops tremendously. And when the pressure drops, that air in their swim bladder blows up. And that's why you need a descending device or a venting tool to let the air out of the swim bladder, or you need to get them back down to depth to re-equilibrate them.
Otherwise, would they just be stuck on the top? Like if you did catch and release and its swim bladder expanded, would it just be stuck on the top?
It depends. So sometimes a fish will be in good enough shape it can swim and get back down to the bottom. But many times they'll try and swim down and it'll keep popping back up, almost like they swallowed a bobber. So they'll be up at the surface, and then sharks and barracudas and stuff come eat them.
Yeah, because they're acting weak.
Or someone drives by and free gaps them.
Yeah, I don't know if you've ever experienced that before.
Last Saturday.
Yeah, okay. All right, so there we go. Air exerts pressure in all directions.
This is Kim Jen and Brito Monsterande.